Happy Friday. This is 2-3 for Algebra 1. We're going to start this off with how we ended the class period yesterday with our school choir needing their shirts. Okay, so we're supposed to write an equation that represents the relationship between the number of t-shirts ordered, the number of colors on the shirt, and the total cost of the order. Okay, so again, we see here it says let D represent the total cost. So we've got D equals, okay, we know that it's $3 a shirt. We know that it is 75 shirts. What we don't know is how many colors is going to be on the shirt. So it is this plus, because we're just going to add that on there, the $50 fee times how many colors there are. So this is our equation that we ended on yesterday. Okay, so now again, kind of reviewing this. In this situation, what quantities do you think can vary? Which might be fixed? All right, we're really looking at pretty much, guys, this 75 members. I'm going to go ahead and count that in the vary just because we could vary things. All right, when we talk about vary, we're talking about our variables. Okay, and so for us, that's going to be the D, the total cost. That's also going to be X, the number of colors that we have on the shirt. And I would even throw in, the 75 in there because that's the number of people. We always could have the members that vary, but the constant is that's what's not going to change. That is what's fixed. Okay? It's fixed. It is not a variable. It's a number. Remember, we said that that's a number. And so for those, that, guys, is going to be the $3 a shirt. It doesn't matter if I buy 5, 20, 10. It's $3 a shirt. Okay? That's fixed. Plus the $50 fee, that is fixed as well on the fee on how much it would be for each color. Okay? All right. So here's our list of table values. What are some strategies you could use to find the relationship between X and Y? Okay, you could try to see, is it multiplying? Am I adding? All sorts of different um, different strategies that you could look at and seeing what they do, or how much do they increase by? We see that the X, that increases by 2 every time, but then we see here, it was we double it every time. So on the Y side, by going 8 and then 24, we're looking at that being what, 16 more, and then we would go up to 24 again here. So you can kind of try to pick a pattern out. Now we look here, plotting the points. What do we see here? Well, we know, all right, well, a couple things that we do know. We know A, that's going to be an exponential problem. And you probably didn't talk about those in 8th grade, but that's something that's going to look like this, where it's not a straight line. What we need to learn is, hey, is it linear? Okay, linear, that's your straight lines. But we just covered this in Algebra 2, so you guys are kind of covering as well, is the fact that, hey, that is, we see here, it's a little tougher when it's not a constant, but we can see what we have there is it's going to be an exponential one that's going to rise. Okay. Now, describe in words how the two quantities in the table are related. What could we say? We look here and it's 0 to 0, 1 times 400, 2.5 times 1,000, 6 times 2,400. What we see here is we're taking X, all right, we're going to describe in words. So you're going to be multiplying, we see here we're multiplying the X value by 400. So see, 1 times 400 is 400, 2.5 times 400 is 1,000. and so forth. So that's what we would put there. All right. Now, and it might be later on, I'm not sure, but if we were going to make this an equation, what could we say? All right, we would say x, and here again, this is where we say that whole times, okay? So we want x, and that gives you this here where you can use the calculator. I'm going to say x. Let's see if we can find a times button. There we go. 400 equals y. Now, how are these related? Ooh. Okay. How are these related? It's a good question. All right, but now we look here, we see a 400, 0, 325, 75. Those all add up to 400. So here we're going to take, so y is going to equal 400 minus x, right? That's how we get that. Because there we take away 0 when it's still 400. We take away 75 and it's still 325. Okay, so I'm going to go ahead. We kind of see what those look like. Go ahead and kind of go here. And let's go ahead and make this bigger. All right. Make this all the way bigger so that we can see. So here we kind of have some of the different ones that we just did. So here it's going to say, when I add them, I get 400. Well, let's look. This one, no. This one I'm not going to add and get 400. Same with this one. So that has to be this one. Hey, we got it right. We're adding. Let's look here. This says 485 and then an 85, 524 and 124. We start to see that the difference is 400. Okay. Which one would that be? Okay. Let's see if this is right. No, can't be that one. Okay, because see, look, it says now we've got x minus 400 equals y, and that's kind of what this looked like, right? I took this, but oh wait, it's 85 minus 400 wouldn't give me that. Let's go up here and look at this. 872 minus 400, that give you 472. Same right here. 998 minus 400, would that give you that? Yes, it would. Okay, so now we're like, all right, how do I do that? But let's look at table C in this equation right here. 85 plus 400, does that give you 45? Yup. 124 plus 400, does that give you 524? Yup. So there is that one. And now we look here. Hey, this is 400 times x equals y. Is that right? Well, 400 times 0 is 0. 400 times 1 is 400. I would say it is. Oh, and let's put those together. All right. So when we see here multiplying the x values by 400, x times 400. Or here's another one. How did you think about the relationships in the first 4 questions? So we can see that they're put together, okay? The main thing that I would tell people is this, what we need to know. And x, when we look at these, x is our input, okay? It's our input, and that is what we are going to be using, okay? X is also our independent variable, okay? Our independent variable. And then we look at y. So if that is our input, what do you think, what do you think y is going to be? That's right. It's going to be our output. Okay, so think of it as a machine. We plug in x, and what we get is the y, which is the output. Okay, then we look here. This was the independent variable. So what do you think y is? Y is the dependent variable. Okay? And also, we need to come back up, and since we're going to talk about graphing soon, okay, x is your domain, and y is your range. Okay, so we have x and y, input, output, independent variable, domain, and range. So that is how we look at the relationship with those. Okay, let's go ahead and bump to here. So here is, says, the table represents the relationship between the base length and the height of some parallelograms. Both measurements are in inches. What's the relationship between the base length and the height of these parallelograms? Okay, so we look here, and what do we see? What do we see? Okay, our height, we've got this, it goes 1, 2, 3, 4, 6. Okay, but what do we notice here? 48, and then I get to 24, then I get to 16, then I get to 12. Okay, is there something that I could do there to get this problem done? It's tough, right? It's tough. So if we were to write this, what is the relationship? Okay, well, it decreases, doesn't it? It decreases. What else could I say? Could I say anything else? And what decreases? So the height, how about this? The height decreases as the base length increases. Okay, so we could say that. So as the height of the length goes, the height gets smaller. Now, visitors to a carnival are invited to guess the number of beans in a jar. The person who guesses the correct number wins $300. If multiple people guess correctly, the prize will be divided evenly among them. What's a relationship between the number of people who guess correctly and the amount of money each person will receive? All right. So this is, again, we're doing that relationship. All right. If I'm going to have 300, I've got that $300. And don't overthink this, because I know in your head, think about it like this. And I believe second hour, Alan and I talked about this yesterday, where I said if Alan, Carter, and Lily and I all bought a pizza for 20 bucks, how much would we owe? $5. How did we figure that out? We took the money right here and we divided it among all of us. So we divided it by the members, and that's what I would say. You take the 300 and you divide it there. So this would be the relationship between the number of people who guess correctly and the amount of money each person will receive. And we could say that this would be the amount that they would receive, just like that. Okay. A half a gallon jug of milk can fill 8 cups, fill 32 fluid, and while 32 fluid ounces can fill 4 cups. What is the relationship between the number of gallons and ounces? If you get stuck, you can complete the table, although you don't have to. Let's see here. 32, it's 32 ounces. Is that, we see that it's half. The 8 to the 4, that's 1/2. So that means that this would be 1/4. Let's see if we got that right. Okay. It says that it's incorrect, but we know that that is correct, that 32 ounces is a quarter of a gallon. Okay, it is a quarter of a gallon. And then here, when we know that a half a gallon jug, that would be 64 ounces. So I'm not sure why it's giving us the X, but we both know that a half a gallon jug has 64 ounces. A 32 ounce cup is a quarter of a gallon because of the number of cups that they have. Okay? So, very, very good. So we look at that. All right. When we look at these, again, It's trying to get you through the process of recognizing those relationships and being able to answer those questions. And with the table, we can actually use numbers to figure out exactly what that relationship is. Okay, so right here, a student starts a new semester with $30 in their lunch account. Each lunch at school costs $1.75. What's the relationship between the number of school lunches purchased in and the dollar amount in the account A? Okay, A. So, guys, we start with this. We want to know the amount that's in there, so we would say that that's A. And then we said that we started the new semester with 30, but then we've got to subtract every time that we eat lunch. So we'd be minusing 1.75 for every lunch purchase. So A equals 30 minus 1.75 in. Okay. So now we look here. A chef is pouring oil from a large jug into equal-sized bottles. All right. This table shows the relationship between the number of bottles used and the volume of oil and fluid ounces in each bottle. Okay. How many fluid ounces per bottle are there if there is B bottles? So we look here, okay, we know, and one things you can do is we see here, it's still the same amount, right, of fluid ounces. So guess what? If we know that we have, I'm going to swipe over, we see that we have 3 bottles and 24 fluid ounces. Okay, 3 bottles, and that gives you 24 fluid ounces in a bottle. How many fluid ounces do I have in total? How many? Well, I can tell you how many. We would take these two things and multiply them together, 24 times 3, and in doing so, we find out that there's 72 fluid ounces in this whole thing. Okay? And we would also find that if we would take 18 times 4, 12 times 6. So it's always going to be 72, all right, 72 ounces, and we're just dividing it by the number of bottles. So if we know that the number of bottles is B, we would just say that it's 72 divided by B. And we would be able to find our bottles based on that. All right, now Claire volunteers at a local library during the summer. Her work includes putting labels on 750 books. How many minutes will she need to finish labeling all the books if she takes no breaks and labels 10 books a minute? Okay, so how would we figure that out? A couple of different ways that we could go about that. We could say that, hey, we want to know when she's 0 books, right? And that's going to be 750 because that's putting labels on our books. That's how many books we have. All right, and we're subtracting the 10 books every minute, and we want to know what that minute is, and that's in. Okay. So we could write it just like that, okay, just like that, or you could say that the minutes is 750 divided by 10. 750 divided by 10 if we put it just like that, and then there's our ratio to see how many minutes. Obviously, we would find that it's 75 minutes. Okay, now we see how much will she need to finish if she takes no breaks and labels 15 books a minute. Okay, so again, same thing, M equals, okay, that's 750, and now instead of putting a 10, we put a 15, and it's going to take her 50 minutes. And so now we see here, suppose that Claire labels the books at a constant speed of s per minute, write an equation that represents the relationship. Well, now we've changed that a couple times. Now it's just going to be 750 divided by s. I'm sorry, I put one too many there. 750 divided by s, and that's going to give us our new equation for that. All right, so that is writing equations in a nutshell, guys, over the last 2 days. Now that we've done that, we're going to be able to do the homework the classwork for 2-2, 2-3, and we should be writing equation pros by now. Make sure you're reaching out to your teacher if you have any questions. Other than that, have a great day.